Okay, so if we're doing, let's talk about Aidan in year six. Okay, the concentration for year six students, I think, should be around 60 minutes. Okay, so if you wanted to organize your day, maybe you could start at say like 10 a.m. Make sure you get enough sleep. Okay, 12 hours might be good. The more sleep you get, the more you can learn, the better you can go. So if you want to do 60 minutes to like 11 a.m., then you can have your recess, and then 11:30 to 12:30, you can go for another 60 minutes. So that's 1, 2, and you can have your lunch, say it goes to 2 p.m., generous lunch, and then you can have your last session at 3 p.m. Okay, and you can go as long as you want really, but like the quality will decrease as you get more and more tired. If you can get these 3 hours in, you're doing pretty good. Okay. All right, so that's kind of like the plan. 2 weeks is really too long to not learn anything. So that's the plan for the 2 weeks if you can do it. And the topic you might want to start with, we'll call it powers of 10. Okay. So I can give you some things to start you off. But it's really important that you kind of go at your own pace, and it's more important to cover something well enough that you can actually use it to understand other things better than to kind of just cover something superficially and move on, okay? So that's what's important. So the powers of 10, what are powers of 10? So powers of 10 are like this. So you have like 1 is a power of 10. I guess that's a trivial power of 10. And then you have 10, 100, 1,000, 10,000. This might be a good time to learn the English words for these things. Huh? So 100,000, 1,000,000, so that's 6 zeros. Okay, 7 zeros would be 10 million. Sometimes we even write that as 10 to the 7 if we can't be bothered to write all the zeros. Okay, but less people understand you than if you just wrote the zeros. Okay, and this is, I guess, where we get the powers from. The power refers to this number at the top. So normally you get a power when you times things by itself. So like a power of 2 is when you times something by itself. A power of 3, you times it by itself again and again. Okay, so here, so notice when you times things 10 by itself, you just add another 0. So if you times 10 by itself 7 times, you get a number with 7 zeros. Okay, it's called 10 million. You know, you can keep going. 10, this is 100 million, a billion. Okay. 10 billion, 100 billion, a trillion, you know, and so on. And then you get to like, you know, what's after trillion? Might get to, quartillion, then quintillion, sextillion. Okay, but another thing, okay, since you've learned fractions, okay, it actually goes another way as well, okay? So it's not just that way, but it goes this way, okay? 0.01, 0.001. So that's like 1/10, 100th, 1,000th. So it's the same things here, but with a th on the end, okay? And you can think of these as negative powers of 10 in some sense, okay? So this would be like 10 to the minus 3. So what that means is you're kind of like dividing by 10 that many times. Okay. So that's what those things are. So everything in the list is 10 times bigger or smaller than the thing that's next to it. Okay. And I guess by the end of year 6, you should be able to understand these well, and you should be able to understand kind of how numbers multiply, divide, add, and subtract, so like all the arithmetic. And I guess the way the numbers all work is because we're working base 10, so these powers of 10 are actually very important. Okay, so even just writing a number like 725 26, right? What that really means is that you have 7 times 100 plus 2 times 10 plus 6 times 1, right? And this 1 could be considered 10 to the power of 0, if that makes sense. There's no 10s there. And then breaking it up like this is how we do lots of our multiplication, right? So, or addition. So if you want to add 700 to, we get 49, right? You're really adding it to 4 times 10 plus 9 times 1, right? And so then you get a 6 times 10 here, plus a 15 times 1, okay, plus a 7 times 100. But the problem is the 15 is you want all these numbers to be less than 10 for it to be single digits, right? So this 15 now becomes a 5 times 1 plus a 10, okay? And this 10 now goes with a 6 to become 7 times 10 plus 5 times 1, 7 times 100, right? So that's where you get 775 from. That's where you get 775 from, okay? And you can do a similar thing with multiplication. This is how multiplication works too. If you were to times them instead of them plussing them, okay, what would you get? Well, you would get, you know, this times 4 times 10 plus 9 times 1, right? So you have to times this by that, and this times that. So you get 7 times 4, which is 28. 100 times 10 is 1,000. Okay? And 7 times 9 is 63. Times 1 times 100. Right? And then you do the same for these other two. So you get 2 times 10 is 2 times 4 is 8. 10 times 10 is 100. Right? Plus 2 times 9 is 18. Plus 10 times 1 is 10. And then the last thing is 6 times 4 is 24, plus 1 times 10 is 10. So it's plus 24 times 10, plus 6 times 9 is 54, times 1 is 54 times 1. Okay, and then this is, to get the number that you want, obviously you can't have these numbers bigger than 10. So when it is bigger than 10, that's what carrying is, right? So you have a whole lot of hundreds here now. So let's start from the bottom. Okay, so you have 54 ones, right? So you can think of that as having 4 ones. Okay, 4 times 1, and 5 times 10, right? And here you have 18 tens and 24 tens. So you can think of this 18 plus 24 plus 5 tens, right? Okay, and then you have 63 plus 800s, which is 70 100s. And then you have a whole bunch of thousands, okay? Okay, so then you can add the tens up. You have 42, 47 tens, right? But you only want 7 of those tens. And then the other 40 tens becomes 400, right? And here you have 70 100s, which is a bit too many. One of the 100s can give you a 500 here, and the other 70 can give you 7,000, okay? And then here you have 8,000 plus 7,000, okay? Yeah, I mean, this last part is a bit complicated, so I guess you don't have to learn this right away. The exercises won't get to that right away, but, you know, the point is, knowing powers of 10 is what gives you multiplication and addition in base 10. Okay, so you have 28,000, you have 35,000 now, okay? So that's what you have. So you have 35,000 574. Okay? Does that sound right? Well, it's sort of right. Like 7 times 5 is 35, right? But now it's 700 times 550. So it's 35 with 3 zeros. So it is kind of like 35,000. So it's not going to be too far off. I made a little mistake or something. Okay, so that's kind of like the theory part of your 1 hour class. It shouldn't take that long, okay? It could be like 10 to 15 minutes. But when you do this 1 hour thing, you have to really do it non-stop. You can't like take toilet breaks, drink breaks, snack breaks, none of this stuff, okay? But after the 1 hour, you can do those things because it's really important to maintain the quality for 1 hour, okay? All right. Now, so the first exercise. Okay, is like this. This is the first exercise. So I got this from the Australian curriculum. But you could get these kind of exercises anywhere, really. Okay. Depending on how long this takes, you can adjust for the next lesson, okay? Okay, so yeah, so the first exercise is it's like this. Notice, even if I haven't told you how to do this, you can try to figure it out, and the order in which you learn these things is not as important as you think. Okay, so Sam says when you multiply, so this is 7.32 times 100. So when you do this multiplication, you get 732,000 or 73,200 because you add 2 zeros. Okay. Will says that can't be right. The answer is 732 because the decimal place moves. Okay, so the first question is anybody correct? Okay. How do you know that? How do you know? Okay, so you can write this on a separate piece of paper. Okay, so you don't. It's not like necessarily yes or no answers. It's a yes or no for the first one, but an explanation. Okay, for the second one. Okay. Okay, so then the next question is, what is the rule? So maybe before this one, you can try multiplying like 10 decimals by powers of 10. Okay, and see what happens. Okay. So for example, actually take 7.32 and multiply out by 100 and see what happens. Take 6.4 and multiply it and see what happens. Okay. Okay, and the last question is, what is the rule? Multiplying decimals by powers of 10. Okay, so that's the first exercise. It could take you the rest of the hour, okay, or it might not take you that long, but I want you to take the full hour without breaks from when I started talking about powers of 10 and try these things. And so, there's two ways to measure the quality of your work here. So the one is if you're actually right. So if you're saying yes or no to the people and you actually get the right answer, that's one thing, but it's not everything. Okay, most people think that's everything. The next thing is how sure you are. Okay, so the reason is actually very important because you can always guess the right answer as well. Okay, and we want to guarantee that the answer is right, so we want to know the reason. And so here is we're doing some explanation, and then at the end we're doing some experiments and we're trying to discover a rule. Okay, and if you know the rule is true, in this kind of certain way, you'll be much more comfortable using it. And when you see something like this next, you can actually use this to help you understand something else you don't understand. Okay, so there's a lot more to get from this than just the right answer.